Hello everyone and welcome to a pure math video. Today I'll be recording a video on integration and let us get started. So, you're all familiar, right, with differentiation by now, hopefully. So, let's say we have y and y equals, I don't know, 3x squared. Find dy by dx. What is the differential of 3x squared? Well, we know that that's going to be equal to 6x. So, what exactly is integration? Integration is just reversing the process of differentiation. So we go from here to here, from here to here, using differentiation, but we go from differentiation back up here using integration, right? So that's exactly what integration is. So let's actually try to integrate something. So first of all, we are going to give it, well, I'm going to show you what the sign looks like first. So to find the integral of something, we'll say the integral of, and we'll say x to the n dx, this is with respect to x, I'll explain this a little bit, is equal to n, to x times n plus 1 over n plus 1. So, looks like a lot so far, right? Looks like a lot. But what this is saying is the integral of x to the power of n. So whenever you see this sign right here, it means integral of whatever is following. X to the n could be anything, x to the 5, x to the 4, whatever, dx. So if you remember, dx, we find the differential of something with respect to x. So this is the integral of x to the n, x to the power of n, with respect to x. And we're saying that's going to be equal to x, the same x, to the n plus 1. So we're going to increment the power. Whatever power x is, we'll add 1 to it. X to the 1 over the new power plus c. And we'll get into to what c means after. C is actually just called the constant of integration. And yeah, I'll explain it in a little bit. So yeah, let's continue now. Let's actually give an example so we can put this to the test. So let's say we asked you to find the integral of root x with respect to x. What is this equal to? So if you look above here, it's equal to x to the n plus 1 over n plus 1 plus c. So it's going to be equal to, first we'll have to switch it into a different way. We can switch this x to sorry, we can switch this root x in a different way that will make it a lot easier to integrate it. Well, I believe it's the only way to actually really integrate it, unless I'm mistaken. So we'll switch to x to the half. If you don't understand this, I'd recommend checking surds. I made a video on logs, indices, and surds, and that explains it. So it's going to be equal to the integral of x to the half with respect to x. So this now is going to be equal to, so what we're going to do, we're going to have x. So let's take our x, because remember that integral of x to the n equals n, sorry, keep on saying n, equals x n plus 1 over n plus 1. So what do we have to do here? Well, we'll keep the x, so we'll say it's equal to x, and then we'll increment the power, so a half plus 1 over a half plus 1, and this is all going to be plus c, which is the constant of integration. And yeah, we'll just kind of make this a little bit neater. So we'll say it's equal to x to the 3 over 2 over 3 over 2 plus c. And to make this just a little bit easier, it's going to say it's 2 over 3 x to 3 over 2. Because when you're dividing by a fraction, you can also just multiply by the reciprocal, and that's the exact same thing. So that was a pretty easy example. Let's try another example. So what if I asked you to find the square root of 1 over x cubed with respect to x? Oh, sorry, I forgot the plus c from here. Please don't forget the plus c. It's actually wrong if you forget the plus c. So integral of 1 over x cubed with respect to x. So this is going to be equal to, so what we'll do first is we'll bring this power, well, we'll bring this down here and we'll put it up to the top. Oh, that marker actually looks kind of disgusting. So we'll bring this power up here. And by doing that, we just have to change the power, right? So it's going to be equal to the integral of x to the minus 3 dx. Now, what do we do here? Remember, we add 1 to the power and divide by the new power. So when we're solving, this is going to be equal to x to the minus 3 plus 1 over minus 3 plus 1 plus c. Okay? So what is this equal to? This is then going to be equal to x to the minus 2 over minus 2 plus c. And we can break this down just a little bit more. So instead of saying x to the minus 2, we can say it's equal to negative a half x to the minus 2 plus c. And these are kind of just the basics of integration. I'm hoping that you are understanding so far. So hopefully you're getting it. It's not that hard at all. Just increase the power by 1 and divide by the new power and add c. Very simple, right? So we'll go through some integration theorems, right? So first of all, you know that d by dx of we'll say 5 is equal to 0 because the differential of a constant. So differential of a constant. So if this is equal to 0, how could we find the integral of a constant? So because of this, right, the integral of a constant. So say the integral of 5 is going to be equal to what? So what it actually is equal to is just equal to the number, which is 5, times x. We'll just put x to it because so let's try it. Let's give an example, right? If we had d by dx of 5x, this would be equal to 5, right? Right. So that means if we take the integral of 5, we should get back up to 5x, right? And we just found the differential of 5x is equal to 5, and so the integral of 5x is equal to 5. Integral of 5x equals 5. But integral of 5 equals 5x. I'm sorry. But yeah, you get the point now. And this is what we need to know. We need to know that. Also, so I'll give you an example real quick. So find the integral of 4 with respect to x is going to be equal to what? Think about it. 4x plus c. Perfect. And we can move on. So what you should also know is that the integral of a sum is equal to the sum of the integral. And what does this mean? It's a very intuitive once you've done logs or something like that. So I'm saying the integral of f of x plus g of x, and this is all going to be in brackets, integral of f of x plus g of x, is equal to the integral of f of x plus the integral of g of x. Right, very, very simple. Just know that, and this works the same plus or minus. It works the same. Let's continue. So I'm going to ask you right now to integrate something a little bit more challenging. Not really challenging at all, but you should be able to do it. So I'm going to ask you to find integral of 6x squared minus 4x cubed plus x with respect to x. So what would this be equal to? So remember, we can break it out. So something else you need to understand is we can break constants out. So this is going to be equal to the integral of 6x squared minus the integral of 4x cubed plus the integral of x. And all of these should have with respect to x, but for the sake of teaching purposes, I'm just going to leave that out for now. And now what you can do is you can remove the constant. So this will be equal to 6 times the integral of x squared minus 4 times the integral of x cubed plus the integral of x. This one doesn't have a constant. And then we'll just integrate it. So remember that when integrating, you just add 1 to the power, which is just going to be 6 times x to the 3, because we add 1 to the power over 3, minus 4 times x to the 4 over 4 plus x to the 2 over 2. Please note that this is just x to the 1, because any number to the power of 1 is itself. So we're just adding 1 to that power. And we can just kind of simplify this. So it's going to be equal to 6. It's going to be equal to 2x cubed when you multiply these. This goes, 3 into 6 goes 2 times. Minus 4 for x to the 4 plus a half x squared plus c. And that's your answer. And so integration is really not that difficult. I am hoping that you're finally kind of starting to catch on. And if you are, then that's good. We're going to move a little bit, just a tiny bit faster, okay? I'm going to give one more example and we'll call it quits for the video because you should be able to understand it by now. Or if you don't, that's fine. You can also just check other YouTube videos out. Whatever works. Good luck on your exams, by the way. So I'm going to ask you to find the integral of x times x plus 2 squared. So what will this equal to? So this will be equal to the integral of x times. Now we want to expand x plus 2 squared, and you know that is equal to a squared plus this. Remember. So your binomial expansion, you can remember that. Hopefully you do, and if you do, then this will be very easy for you. This will be equal to x times x squared plus 2 plus 2 times x times plus 4x plus 2 squared, which is 4. Then we just expand this x. We just multiply by everything in the brackets. We distribute it, sorry. So it will be the integral of x cubed plus 4x squared plus 4x. And remember, to integrate this, we could just integrate it normally, or we could say the integral of x cubed dx plus 4 times the integral of x squared dx plus 4 times integral of x dx. And perfect. Now we just have to actually do the actual integration part and we should be done. So this is going to be equal to add 1 to the power, which is x to the 4, and divided by the new power, which is 4, plus 4 times add 1 to the new power, which is 3. 2 plus 1 is 3 over 3, plus 4 times add 1 to the power, which is 2, x to the 2 over 2. And perfect. Now let's just simplify this. It's going to be equal to 1 over 4 x to the 4 plus 4 over 3 x to the 3 plus 2x squared plus c. And that is integration. This is also called the indefinite integral. This means that there are no limits in this integration, and I will of course teach you some integration with limits very soon. But right after this, I'll be teaching integration with trigonometric functions, and we'll continue from there. If this video is helpful to you, I hope this video is helpful to you. But if it is, then you can always comment and say that it was. If not, please tell me where I can improve. I'm also a student learning for CAPE, and I hope this video was of some use to you. If not, check out other videos and do not give up. Pure math is not that hard and you can definitely do well on it. Good luck.